Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so as you see your screen here now, we are I'm preparing a video to help you start and continue your solving the question of past year questions that you have in your lecture notes. Okay, in your tutorial book. We're still in topic 5, function and graphs. Okay, before I continue, I do hope that all of you willing to click we go to the button subscribe, like, share and notification button. Okay, without wasting so much time, we continue. So these are a few questions that I chose or select from the collection of past year. Please refer to your tutorial book, which is question of 3, 7, 13, 19 and 27. Okay, let's take a look at the first one here. The function given by fx equal to natural log of x and gx equal to e power of x plus 3. So state the domain and range of f and g. Okay, now fx equal to natural log of x. As we know that given a function of y equal to natural log of x for a while. Okay, and if I substitute with natural log of 1, okay, let's say x equal to 1 equal to natural log of 1, then the value or result equal to 0, which means that when x equal to 1, y equal to 0. And then if I substitute x with 0, which is natural log of 0, then the whole function is undefined. Okay, so it means that here, okay, when x equal to 1, y equal to 0, intersect here, x equal to 1. And when x equal to 0 here, then the whole function undefined, meaning along this y-axis is where the value of x equal to 0. So the graph, okay, the function will have no value of y when x equal to 0 is undefined. It seems that it's just like the line, the y-axis or x equal to 0 is what we call the vertical asymptote. Vertical asymptote is where the graph will getting close and close, approaching to the line, but it won't touch or equal or intersect the line at all. Okay, so in this case, it comes something like this. Okay, so this is the function of fx equal to natural log of x. Okay, and then state the domain and range of f. The domain of f and the range of f. So the domain here is approaching to 0 from the right side. Okay, approaching to 0 from right side, and all the values of x which is positive. So the domain is from 0 to positive infinity. What about range? Range, if we appoint every single coordinate or point on this graph, point it to y-axis. So we can see all the values of y is being mapped by the function. Okay, so then the range is all the values of real numbers. Okay, and then gx equal to, okay, gx equal to ex plus 3. Oh, sorry. Okay, and suppose okay, y here. So let's take a look at the function of Okay, let's just imagine that if the function is gx equal to e to the power of x first. Okay, so for this graph, e power of x is a normal, we call graph of exponent. Okay. Intersect at y equal to 1 and approaching to, sliding down here, approaching to the line of x or to the x-axis, or this is where y equal to 0. Okay. Now, when x equal to 0, e power of 0 equal to 1. There you go. X equal to 0, y equal to 1. Now, back to the original question here, plus 3. E to the power of 0 plus 3. E power of 0 equal to 1. 1 plus 3 equal to 4. Okay. Now, just imagine that this graph shift 4 units above. The shape remain, but then it shift from position from here up to here. So then, there you go. Okay, so this is where e power of x and this e to the power of x plus 4. And then this is what we call, as we assume this as an horizontal asymptote, where the graph sliding down approaching to the line of y-axis, but x-axis, but it won't touch the line at all. So now this line shift 3 units above here. Okay, where y equal to 3. There you go. So now I clear this. Okay, this one and here. Now, class, this is the graph of e to the y, gx equal to e to the power of x plus 4. Now, the domain of this function of g and the range of g. So, what is the domain of this g? The domain is all values of x. Actually, this graph will remain, okay, continuing with no end. So, it's all real numbers. And the range is, okay, with the least value approaching to 3 to positive infinity. So then 3 to positive infinity. There you go. Okay. State the domain and range of f, domain and range of f and g, and then sketch the graph. There you go. Now, find the function of f and g defined here. Find f inverse and g inverse. So then, let fx equal to y. Okay, fx equal to y here. Y equal to 3x plus 4 divided by x minus 2. Cross multiplied here for this one. Come up with xy minus 2y equal to 3x plus 4. So bring this 3x to the left side and bring this 2y to the side. So xy minus 3x equal to negative 2y. Bring to the side become positive. So then 2y plus 4. Factorize the x. Then x equal to 2y plus 4 divided by y minus 3. So the f inverse equal to 2x plus 4 divided by x minus 3, where x cannot be equal to 3. So that is an inverse function of the f. And then also let y equal to gx for the function of g. So then y equal to 3 minus x. Then bring this 3 to the side, become negative. So y minus 3 and x equal to 3 minus y. Y minus 3, negative 3 minus y. Okay. So then g inverse of x equal to 3 minus x. Okay. So this is the inverse of the function g. Okay. Now evaluate f g inverse where x equal to 3. Okay, g inverse we have found it earlier, which is 3 minus x. Okay, and then substitute the value of x with x equal to 3 here. So 3 minus 3 equal to 0. f0 equal to, substitute 0 into an x of the function f. So then 3 times 0 plus 4 divided by 0 minus 2. So 4 divided by negative 2 equal to negative 2. Okay, and then next one here, let's say g and f inverse where x equal to k right now. Okay, so replace the x with a k and it is 2 over 3. Okay, so the first time, okay, now what is f inverse? This one here, and substitute x with k. So then g 2k plus 4 divided by k minus 3 equal to 2 over 3, and substitute the whole function into an x of the function g. Okay, so it is now 3 minus x, which is 2k plus 4 divided by k minus 3 equal to 2 over 3. Okay, bring these 3 to the right side. Okay, I'm sorry then. Okay, we got 3 here. Bring these 3 to the other side, become negative 3. And change this in the form of, transform this into the form of fraction with a denominator of 3. 3 times 3 equal to 9 over 3. So then, negative 2k plus 4 divided by k minus 3 equal to 2 minus 9 equal to negative 7 over 3. Multiply with negative 1 and negative 1 here. So 2k plus 4 divided by k minus 3 equal to 7 over 3. Cross multiply, k minus 3 times 7. 3 times 2k equal to 6k. 3 times 4 equal to 12. 7 times k, 7k, and 7 times negative 3 minus 21. So bring this 7 to the side, become negative 6k minus 7k, negative k. Negative 12, bring out here, become negative, so negative 21 minus 12, negative 33. Then k equal to 33. Okay. Next. Then fx equal to e to the power of 3x plus 4. Find f inverse. So let fx equal to y. So then y equal to e power of 3x plus 4. Okay, so e power of 3x equal to 4, bring to the side, become negative, so y minus 4. Okay, for exponent, Euler's constant, okay, for Euler's constant specifically, we eliminate this by come out with a natural log on the left side, okay, because ln is a log to the base of e, okay, log to the base of e, and e power of 3x, bring this 3x to in front here, log e to the base of e equal to 1. So then also come out here with natural log. So 3x equal to natural log of y minus 4. And x equal to 1 over 3 natural log of y minus 4. So then f inverse equal to 1 over 3 natural log of x minus 4. There you go. So on the same axis, sketch the graph of f and its inverse, state the domain of f and f inverse. Okay, y, x. Okay, let's sketch this first. E power of 3x. Okay, now generally, the difference between y equal to ex and y equal to e power of 3x, the shape are actually the same. Okay, when x equal to 0, x equal to 0, e power of 0 equal to 1, 3 times 0 equal to 0, e power of 0 is still equal to 1. So they intersect at y equal to 1 here. First, the graph of here. Okay, this is the graph of ex, and the other one here, this is graph of e to the power of 3x. Okay, so that's the difference, where we call the gradient is different, but then intersection and the shape are yet still the same. Okay, now e power of 3x. Okay, so the graph will be something like this. Y equal to e power of 3x. So when it comes to when x equal to 0, okay, let f0 equal to e to the power of 3 times 0 plus 4. 3 times 0 equal to 0, e power of 0 equal to 1, 1 plus 4 equal to 5. So when x equal to 0, y equal to 1 plus 4 equal to 5. When x equal to 0, y equal to 5. Okay, this is 1 and this is 5, meaning the graph shift 4 units above. Okay, 4 units above, then the shape is still the same. Okay, this is y equal to e to the power of 3x plus 4. And then we call this line of the horizontal asymptote also shift 4 units above, and it's become 4 here now. Y equal to 4 is the horizontal asymptote for the graph. Okay, so clear this and clear this one here and here. There you go. Okay, now this is the graph of y equal to e power of 3x plus 4. This is y equal to 4. So to sketch the graph of f and fx on the same axis, we need an extra line of function y equal to an x. Okay, so we bring up, okay, shift the position of y equal to 5 here, bring it to the x equal to 5 here, and y equal to 4, bring here x equal to 4. Okay, so just imagine that this graph we call shift to the other side with a unit. If this is 4, then it's also 4. Okay, or in other words, I can say that this is a reflective mirror, so the distance from this graph to this line equal to the line of y equal to an x to the graph of the image. So then it is something like this here now. There you go. This is y equal to 1 over 3 natural log of x minus 4. Okay. Next. Okay. Before we look into the, okay, never mind. Question A, show that f is a one-to-one function. F x1 equal to f x2. So square root of 3 minus 2x1 equal to square root of 3 minus 2x2. So we squared left and right, cancel between these two. So we got 3 minus 2x1 equal to 3 minus 2x2. So minus 3 and minus 3 here. So we get negative 2x1 equal to negative 2x2. Divide by negative 2, left and right, it gives you x1 equal to x2. So then, come up with the conclusion that fx is a 1-to-1, okay, 1-to-1 function. Okay. So, to find the domain and range of f. Fx equal to square root of 3 minus 2x is defined when 3 minus 2x, the function inside, is greater than or at least equal to 0. Okay, so from here, 3 minus 2x greater than or equal to 0. Okay, then negative 2x negative 2x greater than or equal to negative 3. So we divide by negative 2, left and right. Divide by negative, it will affect the direction of this sign and come out with x less than or equal to 3 over 2. Okay, class, automatically, this is your domain of the function f, which is from negative infinity until 3 over 2. 3 over 2. Okay. And then, the graph of this function, okay, the graph of square root function here, where x is begin from 3 over 2, okay, and x less than or equal, meaning that the value of x goes to the left direction, all the negative here. And then the shape will be something like this. Okay, so this is the shape of the square root function. So if you refer to if you point this graph axis, you can see it's begin with 0 and all values of y above is being met by the graph. Okay, so the range of this function equal to 0 to positive infinity. Okay. Domain and range of f determine the inverse function and state domain and range. Okay, so let fx equal to y. Okay, let fx equal to y. Equal to, okay, square root of, sorry, okay, 3 minus 2x. So then we squared left and right. Clear this. Then y squared equal to 3 minus 2x. Okay, so bring these 3 to the side. Negative 2x equal to y squared minus 3. Okay, and x equal to negative 1 over 2 y squared minus 3. So f inverse equal to negative 1 over 2 x minus 3. Okay. So state the domain and range of the function of the inverse of f. Class, as we know that the domain of f is also equal to the range of f inverse, and the range of f equal to, okay, sorry then. Okay, it's happened again. Sorry, technical problem here. Okay. Okay, class, there's a technical problem here, but then I do hope that all of you can just recall, press the button, recall reverse button, and watch it again. Okay, for this one here, if I'm not mistaken then, okay, so we agreed just now that the domain of this function of f, negative infinity until 3 over 2. Okay, please refer to your, the previous minute of this, lecture of this discussion here. And then the range of f equal to 0 to positive infinity. There you go. Okay, so now it's time for us to sketch the graph of this. Okay, so extra line of y equal to an x. Okay, just now it begin the graph of fx equal, starting from 3 over 2, which is 3 1 over 5. Okay, 3 over 2, and the graph is something like this. Okay, now okay, if I bring this 3 over 2 here, okay, here, and this intersection here, so it's gonna be something like this. There you go. So this is f inverse, and the one that I sketched with blue ink is the function of f. This is the function of f. Okay, so this is f inverse, and this is a function of f. There you go. Okay, next. Okay, now given a function of fx equal to natural log of 2x plus 1. Okay, state the domain and range of the function fx. Okay, this is our clue again. Let's say y equal to natural log of fx. Okay, so as we know that natural log of 1 equal to 0. Okay, natural log of 1 equal to 0, and natural log of 0 makes the whole function undefined. Okay, now let's imagine that if we make this one fx, okay, according to the question here, the fx is 2x plus 1. Let's make this one here 2x plus 1, make it equal to 1. Okay, so then 2x equal to 1, bring out here, become negative, so 1 minus 1 equal to 0. Then x equal to 0. Let's try again. Okay, let's try. When x equal to 0, then f0 equal to natural log of 2 times 0 plus 1. 2 times 0 equal to 0. 0 plus 1 equal to natural log of 1. and natural log of 1, y equal to 0. So what is the value of x just now? Yes, x equal to 0. And what's the value of y? Y equal to 0. So they intersect here at the origin point. Okay, and then let's make this one 2x plus 1 equal to 0. Because non-zero makes the whole function undefined. So that is the value of x that we like to find out as a vertical asymptote of the graph. Okay, so then x equal to, bring 1 here, become negative, negative 1, and x equal to negative 1 over 2. Okay, so now x equal to negative 1 over 2. Let's try again. When x equal to negative 1 over 2, so f negative 1 over 2 equal to natural log of 2 times negative 1 over 2 plus 1. Okay, 2 divided by 2 equal to negative 1 here, negative 1 plus 1 equal to 0, then non-zero is undefined. So when x equal to negative half, somewhere around here. Okay, so this is the line of x equal to negative 1 over 2. Okay, so natural log of 2x plus 1 here. Okay, intersection point on the right side of this vertical asymptote. So the graph will be something like this. Okay, there you go. Okay, so state the domain and range of f. So the domain of this function, the domain, all values of x on right side here and here, approaching to x equal to negative half. Okay, so then it is negative 1 over 2 to positive infinity. And the range of f, what is the range? Range all value of y, am I right? All values of y here. So it is all real numbers. Okay, okay, then clear this first. Okay, sorry, my laptop is getting slow and slow. Okay, there you go. Okay, now find the inverse function of f and state the domain and range. Hence, find the value of x for which if f inverse equal to 0. So now, let fx equal to y. Y equal to natural log natural log of 2x plus 1. Okay, so make these two as an index to the constant of E, Euler's constant. So you come up with EY equal to, okay, let's make the EY here and also here, cancel between these two, and come up with 2x plus 1. Okay, then next, 2x equal to 1, bring it here, become negative, so then e power of y minus 1. Okay, then x equal to 1 over 2 e power of y minus 1. So then F inverse equal to 1 over 2 e to the power of x minus 1. Okay, so this is your function of fx and this is your F inverse. Find the value of x for which F inverse equal to 0. Okay, so F inverse equal to 0. One over 2 okay, 1 over 2 e to the power of x. Sorry. Okay, if I can't complete the discussion of this, so I just let all of you to try by yourself with only question of B and C to end of this session. Okay, so F inverse 1 okay, so 1 over 2 okay, e to the power of x minus 1 equal to 0. Okay. So multiply with 2 here and multiply with 2 here. Yeah, okay. Multiply with 2 still give us 0. Then ex minus 1 equal to 0. Then e to the power of x equal to 1. Okay, so we are going to find out what's the value of x here. So come up with natural log on left side and here. Okay, clear between these two, then x natural log of 1 equal to 0. Okay, so class, which I think that, okay, never mind. Let's and finish up this discussion video here. Here you go. Okay. Y okay, this is an x and this is y. Okay, so a line of y equal to an x. Okay, now the graph of this intersect at negative half here. Okay, something like this. So this is the graph of fx. So its inverse. So just imagine that there's also, this is horizontal vertical asymptote, x equal to -1/2. This is horizontal asymptote, which is y equal to -1/2. Okay, so the graph of blue here, fx. So then the graph of this, okay, class. To make a clear picture of how to sketch the graph of what we call in this topic, I do strongly suggest to all of you to use this website, DESMOS.com, www.desmos.com, okay, where you can just simply substitute the equation of y equal to any fx and it straightly give you the picture of the graph. Okay, so this is a graph of fx, this is a line of the reflective mirror, and this is a graph of f inverse. Okay, that's all for today. I'm sorry for the technical problem during this lecture, but then I do hope that all of you know how to handle it. Okay, so till we meet again, Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.